Hello, everyone. Welcome to episode 2 of the Day Zero podcast. I'm Spectre. With me is Z, and Auntie won't be joining us this week. He had a previous commitment, so he will be back next week, though. So it's just going to be the two of us today. And so this stream is titled CSGO-Days, Mitigations, and voting systems. So those are going to be the main topics we're going to be covering. And the first thing we're going to talk about, I think, would be the CSGO days. Would you be good with that, Z? We started with that?
Yep.
Okay. So I don't know how much you read into it, so I guess you can pull up the browser now. So it was disclosed from HackerOne, which is like a bounty platform, and the weakness, classic buffer overflow. So I guess it is a bit disingenuous to say it's just a CSGO day. It's actually in the Steam client, so it affects Team Fortress 2, Half-Life, and CSGO. But it's essentially a server, like a client exploit that can be exploited by the server, and it's a Stack Overflow with a player name, that the server sends over to you. So it's kind of an interesting report. I thought one thing that was really cool about it was they had to worry about Unicode because the player names are in Unicode. So they had to use gadgets and stuff that didn't have like null bytes in the address and stuff like that. So I thought that was kind of really cool.
Yeah, I mean, no null bytes is pretty normal for the kind of classic buffer overflows, but I do like the fact that this really is your traditional buffer overflow. They're literally, spamming the buffer, overflowing it, overwriting EIP, and away they go. Now, in their exploit, they do a ROP chain from there to turn off the stack protection, then execute their shell code, but it's a pretty classic style of attack. I don't think their script deals with ASLR, which you'd have to if they were actually trying to exploit this. But
Yeah. The other thing is there is another. So not only was there the null bytes, but they also had a bit of a restriction on the addresses they could use because if it was invalid Unicode, it wouldn't work. Um, but yeah, and that's kind of funny, right? That we're in 2019 and there's still software out there that you can just easily exploit a Stack Overflow like that, ASLR aside, because there's no, for some reason, there's no stack cookies in the server browser library. So,
yeah,
uh,
I mean, we could debate the use of stack cookies, though. I mean, it does have a huge performance impact, so putting it everywhere, it doesn't really make sense. Um, I mean, on server code, I could see more of a reason, especially kind of in this case where it seems to be communicating kind of with player run servers. There's not a good reason to even trust it to begin with.
yeah. Yeah, and I guess the other thing is too, games haven't really been considered too much for like a payload delivery method for like malware and stuff like that. They don't typically hit games, they hit more like browsers and stuff like that.
Yeah, I
Um,
mean, there's. Do we want to jump onto the next one or
well, I was
the
just gonna
CS
say,
one?
like, you know, these engines, like the Steam client and even like Source Engine and stuff like that, the code is pretty old, right? Like it's some of it is from like the 90s, and they don't really keep the code up to date and don't adapt newer security mitigations. So I guess that could be like uh, a consideration in that.
Yeah, so I mean, in terms of the clients being hacked, though, that is something you kind of hear rumors about every so often. I mean, it's definitely not the first time I've heard about the games being hacked. Like, it's definitely happened in the past. Um,
Yeah,
but if we kind of look at the next news report, there's on CS 1.6 malware campaign.
yeah. So
I mean, I
this is the one here.
yeah, I think that's kind of a really interesting case because so often you kind of have these malware campaigns are doing malvertising is kind of the big thing right now, and
Yeah.
um, I mean, this with the game, this is the first time I can really think of where it's a malware campaign through the game client. There's maybe been other cases of it that I'm just not familiar with, but the only kind of exploit through the game, like probably just kind of a favorite little story to mention is, are you familiar with Ratchet and Clank Up Your Arsenal? It was on the PS2.
I think I played it, but it was a long time ago. But
So
yeah, I'm familiar with the Ratchet and Clank games. Yeah.
yeah, well, so what they did, they didn't have any way to update their game when they kind of released it. So
Okay.
their update method was actually a buffer overflow in the EULA, the end user license agreement. They would basically just overflow that until they reached a function pointer and then update the game that way. So like, there have been exploits in games, for quite a while,
Mm-hmm.
but I haven't heard of them too often being used for malware. I've definitely heard of them being used on like very specific cases to infect someone in particular.
Yeah, and the other case where they're kind of used, I guess, would be like console jailbreaking. So games are like other than the browser, games are probably like the second best vector for trying to get code execution on consoles too. But for malware, yeah, I haven't really seen it used much.
Yeah, so I mean, the other thing is that this one actually exploits both. There's two of the remote code executions there in the game client, like the stock game client you get from Steam. But two or four, the report you've got up mentions four, but the other news report only mentions two of them. So I'm not sure how many 0 days were dropped with this or were found with this. But two of them were two or four were in pirated copies, like specific to the pirated copies of the game, which I thought was a little bit on the intriguing side that they're looking at infecting the pirated users also.
Yeah, and I heard something where even legitimate users, the names were getting changed of players to link to the uh, infected client. But
Yeah, that's
yeah.
once they were infected, like once they had I forget the name of the malware, or I'm not even sure quite how to
Oh,
say it, but
oh, Belonard.
yeah,
I'm just gonna call it Belonard. Yeah.
yeah. So yeah, when they'd get infected, that was one of the things they would do is it would change their name on CS 1.6 to whatever their domain was, or if you would kind of download that and kind of get some or get some traffic going to it. Um,
Yeah.
I mean, the actual use of this malware seemed to be more or less advertising legitimate Counter-Strike servers.
Yeah, so I think it promoted both the malicious and the legitimate ones that it were like people paid for. I think is what I read.
Yeah, it seemed to be uh, like they could do like it would use the malicious one. So the way the actual exploit worked is um, basically the infected user would start up a game or start up a game server, and that would be listed as like a proper CS 1.6 game showing there. But when somebody connected to that, it would proxy the request to this malicious server. The malicious server would serve the RC, infect them, and away you go.
Yeah. And one thing I did think was interesting, I can't remember the exact page it was in the report, but it mentioned that they've reported this and like the bug that was used in this malware campaign and a few other bugs to Valve, and they still haven't bothered to fix it. So it's still a 0 day. So they obviously didn't talk too much about the exploit details, but
Yeah,
yeah.
I kind of tried digging into that. They make mention of, I think, some of the files that are impacted by it, but there really isn't enough to comment on like the sophistication of the exploits or anything. But if we use the Steam one as an example, it may be pretty straightforward. Although that's pure speculation, to be fair.
Yeah. And I mean, there is that requirement, like even the Steam one, like you said, there was the requirement for ASLR. And from what I've heard about Source Engine and stuff like that, ASLR is generally the bigger hurdle to overcome. Like you can find quite a few memory corruption bugs, but the ASLR is like a big pain because info leaks are not incredibly easy to pull off on game engines, I guess. So I guess that's another thing too that, you know, I'm really interested if the bug will get publicly disclosed just
So
to
what
see
was the
how they
time
deal with that.
frame that they've mentioned, or did they mention in the larger report a time frame on how long ago they had reported this?
I don't remember seeing where they said that.
Yeah, I don't recall seeing it. That's why I thought
Yeah, it
maybe
just
you
says
had.
we previously reported the similar incident, but yeah. Oh, so yeah, so it refers to a previous. So there was another malware campaign before this too, but it required user interaction, so it
Yeah,
wasn't
I
as
had seen
powerful.
that, so I didn't kind of include it when I was mentioning it. Because I mean, yeah, there's plenty of Trojans for
Yeah,
games and stuff. Like, absolutely, you pirate a game, you're probably getting something in there also.
yeah,
I mean that's just a given when it comes to piracy. You can't really trust what you've got. Think about who's providing it to you and what they get from it.
yeah. So yeah, I think that's everything on the CSGO day and the CS 1.60 day. Uh, hopefully we like hopefully more technical details come out about that. Maybe we can talk about that more when they do. Um, going at a bit more of a technical level, we have the WebKit structure ID mitigation, which I actually didn't pull up in the browser. So hopefully it's. I should be able to find it here.
Here, I'll
You know
put
what?
it in.
Just
I've got it.
oh, you've got it. Okay, perfect. Look at that. So I thought this would be kind of interesting to talk about because it is kind of a new mitigation, and so to kind of understand how this like what this mitigation does, I'll talk a little bit about how WebKit exploitation works.
Yeah,
uh,
so like I mean I see structure ID. I haven't done any WebKit exploits. So I mean probably best start off with, what even is a structure ID? How's that used in the exploit or in the normal kind of exploit chain?
yeah, so in WebKit your common goal is to go for a read write primitive. You generally can't really go directly to code execution anymore because of the mitigations that have been put in place over the years. So read write is like the ultimate primitive in browser exploitation. So how you typically achieve that with almost every exploit is doing type like pulling off type confusion in the JavaScript engine to create a fake array that'll let you like read and write to arbitrary addresses. And so how you do that is you have to fake what the engine thinks is an array. So in WebKit internals, there's tons of objects that represent different types of variables that you would use in JavaScript. They're called JS objects. So you can have a bunch of different array types, like just a normal array of integers, or you can have like a uint32 array that points to like a backing buffer. Like there's a bunch of different arrays you can use. And how like the engine knows the difference between these types of objects is through a structure ID. So it's like a unique identifier kind of for that object type. So in order to exploit and fake the type of object you want, you need to know what structure ID to put there. So that's kind of why it's a mitigation to kind of try to randomize the structure ID.
So then are most of the attacks then involving faking an object somewhere on the stack or on the heap?
It's faking an object through it's in the heap, but it's a bit complex. The way you have to do it is you have to use an already existing object because some objects have something called inline slots that'll have like values put close to it so that it can access them faster before going into a different heap arena. So you basically fake the object inside of another object. But
All
yeah,
right,
it's
yeah.
mostly in the heap. Yeah. So yeah, so the typical method of see the interesting thing about structure IDs, and this is mentioned in the JavaScript attacking JavaScript engines by Salo on Frack is the structure IDs aren't static. So you can't just look at the source code for WebKit and find out what the structure IDs are going to be. They're generated at runtime. So already in exploits, you kind of have to do a little bit of magic to try to get the right structure ID. So the way of doing it before was like spraying a bunch of objects to try to get structure IDs generating, and then you use the instance of JavaScript built in to see that you got it right. So you do like target object instance of uint32 array or whatever, and that would tell you if you got the right structure ID. So you already had to do a bit of spraying just to try to get the right one. But now with this randomness implementation, that could be even more difficult because of these additional bits they've added in for the randomness.
Yeah, so you're already spraying, so that means like you don't know what those 57 bits are, or 24 in the first case, whatever. You don't know what those bits are, so you've got to predict those. Plus now they've got some presumably truly random 7 bits of entropy. Have you looked into the randomness there? Like,
I haven't looked into it too much. It is a bit complex, especially where it's generated at runtime. So, like, I've heard that I don't think it's going to be a mitigation that's going to cause, it's definitely not going to kill WebKit exploits or anything like that.
no, I mean
I
it's
think it's
just kind
just
of the extra step.
yeah,
I mean it doesn't seem impassable at all, just more work.
yeah, and WebKit exploits are already too much work, so I guess it's just another rung on the ladder for WebKit stuff. But yeah, I just wanted to bring that up as I thought it was interesting. It's a newer thing.
Yeah, I mean I've not dealt with anything that kind of does much similar to that, just in the sense of tossing in random bits. Because I mean, it's not an ASLR thing. It definitely it
No,
works very differently than that. It's a very specific mitigation to
yeah,
WebKit attacks.
yeah, like browser exploitation or like browsers in general are kind of unique with the way they like there's like type confusion in WebKit can propagate into so many things. Um like the smallest issue you can turn into a weaponized bug, and this is like just one of the ways you can do it. So, yeah, I don't think you'd really find anything like this in other software other than browsers really.
So, what are your thoughts though on getting around that? I mean, I kind of mentioned towards breaking randomness. I'm going to assume that that's not really going to be an option.
Yeah, honestly, I'm like you still have that instance of
Like you can
the
still kind
instance
of
of
brute
operator.
force it. It sounds like.
Yeah. Yeah, that would be probably the way I would think, is just trying to, you know, spray but try to identify patterns maybe in the indexes and stuff to like uh limit the time it takes to find a valid structure ID. But yeah, other than that, I can't really think of one at the moment. I haven't really tried anything on like post
Yeah. So
WebKit post dispatch.
how often would you come across a gadget that wouldn't, or come across an issue you could use that wouldn't require faking a structure? Like I know that seems to be kind of part of the primary target, MO of sorts for this type of exploit, but are there strong reasons why you can't start looking at other areas also?
No, not really. It's just that this is kind of like the meta way that it's done. You could probably go another route. See, the thing is too is the ability to fake an object is just so incredibly powerful, because not only can you uh like make a fake object to get read write, but you can also leak um arbitrary objects. So you can create your own info leak with it, kind of. So that's why it's kind of the meta way right now. There is definitely other ways you could exploit WebKit, probably without even needing to mess with this, but I don't really know them. Or
It's that, and I
yeah,
mean, this is where, like I said, not knowing it and like a lot of information's available about this particular um, strategy, I guess, or about this area of the code. So you have to do a lot more work to kind of push into other areas, I'd imagine.
yeah, yeah, and a lot of you need a lot of research, and WebKit is like the code base for WebKit is insane. So you kind of you would really have to put in a lot of research to find another strategy that would work as effectively, I think. So yeah, I guess that's everything about the WebKit stuff. There's not too much to really discuss there. I just wanted to bring it up. So I guess we're on to the reuse gadget counts. So I know you posted this
Yeah, so I'll kind of talk
right
quickly
here.
here. There's recently a paper. It's a little bit older than the stuff we'd like to cover in this podcast, but as we're just getting started here, I figured it was worth maybe talking about it a little bit. Um, I mean, it does kind of relate to the WebKit stuff or just exploits in general. Um, using ROP, JOP, all those fun techniques. You kind of end up focusing on finding gadgets that you can use, gadgets that can be repurposed in your exploit to do whatever you want. Made it a little bit easier on like the x86 style architecture because those all the multi-byte instructions can be interpreted multiple different ways. Although, if we want to jump back really quickly, Dibma, I'm not sure how to say your name, is mentioning that the Nintendo Switch, I guess they removed all the web engine stuff. Was the Switch WebKit? You recall?
Yeah, yeah. The so they like right off the bat with the Switch, they didn't have a standard browser feature like a lot of consoles do. Probably because they didn't want it to get pwned over the browser. But
Yeah, I remember that being a pain point for a lot of people. Actually, is like you can't just use this as like a semi-tablet device.
yeah, but there were still ways, especially I think the way they used for like the big exploit that went out was there was a game that had a user license agreement, I think, or something like that in the game where when you clicked on the hyperlink, it opened up a browser
There
window, and
was
that
that,
was
and didn't
WebKit.
it?
So
Wasn't there captive portals also?
yeah,
Wi-Fi captive portals or whatever would prompt you with the browser.
yeah. So that's the new way they go about it because I don't think that was in the Switch on day one. I think that was something they added later. I might be wrong on that though because I don't do much Switch stuff. But yeah, that is the newer way because you don't have that requirement for game specific games or anything like that.
Yeah, so I mean, I guess that's another place just where WebKit is um, a juicy target. But yeah, so
Yeah,
let's get back onto kind of the code gadgets. So as I was kind of saying there, with ROF, with JOP, you're kind of trying to find these existing code gadgets that are useful for, or that can be repurposed in your exploit. You can't put your shellcode on the stack or wherever. You need to put it somewhere. Go ahead.
yeah. So I was just gonna say, so yeah, I saw it talking about software bloat. So trying to, I guess, cut out code that's not used
Yeah,
to
and
reduce the amount of gadgets available.
the idea there being, less gadgets it stands to reason that if you have fewer gadgets, then it's going to be harder to generate your ROP chain or your exploit chain. If you have fewer gadgets to work with, stands to reason that it's going to be harder to actually produce a useful chain.
Yeah. So I saw the overall premise of the paper was basically that, uh, software debloating doesn't really help in regards to return oriented programming
Well, so
for attacks.
they looked at like ROP, JOP, and COP stuff, not just the ROP. So that's definitely to their benefit. What I found interesting was that they found that in some cases, albeit a minority of it, uh, they found that debloating the software resulted in more gadgets that could be used rather than less.
Yeah.
Yeah.
I
In
remember
in
seeing that
most
too.
cases, what they found, it was like 20 of 24 cases. It was just different gadgets, fewer and but it did introduce new gadgets, which is one of their arguments. So by the title there, their whole point is reducing your software size or debloating doesn't necessarily lead to better security. That's kind of
Yeah.
their big point there. And so one of their arguments is, yeah, you've reduced the gadget count, but maybe you've given them newer or better gadgets. I mean, what matters is the quality of the gadgets. I mean, ultimately, your ROP chain is normally only using a very small percent of all the available gadgets that you've got.
Yeah, for
As
sure.
long as you've got the just the right gadgets, it reminds me almost a bit of like the cat and mouse game that's there, where people were doing like you could only enter lowercase letters or uppercase letters or like just alphanumeric and limiting input like that on some software years ago. And then it's like, well, you can build your shellcode out of alphanumeric or just alpha even. Like you could do that. And that's what this kind of reminds me a lot of. It's like, yeah, okay, you can reduce the gadgets, but it's anybody who's kind of sitting there looking at it is probably going to be able to figure something out.
Yeah, I mean, especially with like calling conventions and stuff, I don't think it's really possible to cut out all the gadgets that or like any of the gadgets really that an attacker would need. Like let's say that like, this gadget would probably always exist, but let's say they managed to cut out like, strip a software of its bloat and there was no move RDI RAX gadget. Well, like there's so many other registers that they could use. Like it's just you can get so creative with how you use ROP chains that I really don't think that debloating is really going to help much there.
No, but at the same time, I guess there's kind of thing that is it still not a positive step for security in general. Like what they did find was that the number of gadgets were reduced in most cases. Like I said, I did find it funny that sometimes debloating resulted in new or more gadgets, and that just comes down to this is source level debloating for the most part. Um,
Okay.
so they're not really getting rid of specific instructions. They're more looking at source like this is dead code, get rid of it, and that ends up resulting in the compiler, maybe different optimizations. Chooses to unroll loop here, do something different elsewhere. Maybe the uh, removes the switch jump table on just like a branch or something.
Yeah.
Little things like that end up introducing more, but at the same time, is having less not still kind of a positive step towards that security? It's not the end all be all. It's not stopping a ton. I I don't really agree with their conclusion. Their conclusion is that as part of like your secure software lifecycle or development lifecycle, you should have a human looking at the ROP gadgets and deciding whether or not you should debloat or not.
The, a human. Okay, that's really interesting.
Yeah, like I definitely don't agree with that push. Like that's just adding too much work in there. They do, try and have it so it's analyzed by a computer, kind of having some help there.
Yeah. I mean, so jumping back a little bit on what you were saying with how debloating could be better, the one area I guess it could be better is JOP gadgets. Typically, you're already much more limited with JOP because you have to be able to control where you're jumping to after that gadget. And,
Yeah, you need that
you know,
one specific gadget there. Well, not one, but like you need the ability to do the jump table.
yeah. And I think, you know, if you can eliminate those gadgets, like that could be extremely damaging to somebody trying to do job. But probably not so much Rob.
Yeah, and it looks like what they've looked at is mostly around source. deep loading, whereas kind of getting on those gadgets is going to come down to like dealing with the binary, and I'm not sure if much research has been done on that. Just as a quick aside, Anime Weed Dad 69. Deep loading absolutely sounds dumb, and it is not a replacement for something like RetGuard or so many other mitigations out there. And I definitely don't want to come across as though everybody needs to be doing this deep loading because, frankly, I don't think it's necessary. I think it could be a step that's kind of on there. Like I do think it's. I'd still argue that there is a generally positive step by doing the deep loading, but it's not something that I think really needs to be adopted.
Yeah, I mean, I think it's more for the performance angle than anything. I don't think it should really be treated as something for the security angle, if that makes sense. Like,
Yeah, well, I mean, with performance, though, your performance in theory hasn't changed too much. If you have issues in your architecture, they're still there. So
yeah,
your performance is going up. I mean, you're getting a smaller binary in theory.
yeah,
So I
that's what I
definitely
mean.
see
Like, yeah,
security applications to it. I'm not going to propose that this become like the next big mitigation that gets implemented. I just thought it was, an interesting argument here. It was made, a couple weeks ago or whatever. So I thought it was, worth taking a look at. But yeah, I mean, for this uh, anime we dad, it definitely doesn't replace a lot of the real time or even some of the compile time options to try and deal with ROP, CFI and all that fun stuff.
yeah. Okay, yeah, I think that's covers
Yeah,
the reuse gadget counts paper pretty well.
yeah.
The other
So
thing.
go ahead.
Oh, sorry. Did you want to say something?
No, go ahead.
Oh, okay, so I was just gonna say the other thing that you brought up was also the DTrace on Windows. You wanted to talk about?
Yeah, yeah. So I mean, DTrace has been around for a while, not on Windows, but on Linux, on yeah, Mac has had it. I'm pretty sure it's on FreeBSD. If you're not familiar with it, it's just kind of like a more general, more powerful like strace, ltrace. You're essentially able to write little programs. To me, it feels like using awk. It has its own little programming language. Reminds me a lot of awk. I'm not sure if you've ever worked at all with awk,
No, I
Spectre, but
haven't.
yeah. So
No, not really.
I won't dive into it too much. It's just a very basic little language, not Turing complete. You don't have loops, but you can do things. You can set some variables. You can print stuff. So what DTrace does is it basically lets you. So first off, it runs in kernel space. So performance definitely mattered when they were building and building out that language. And you basically have, or you set up probes. When a probe is hit, you can write code that will be executed on that probe hitting. So one obvious thing would be like on syscalls. Every time you hit a syscall, you can like prompt, what syscall was this, or take count, or increment a variable to count how many times you hit that. Um,
Oh,
it basically just lets you trace all those syscalls. Some applications, big things like the JVM or MySQL. In the JVM, you can have a probe on like thread start, stop, class load, unload, garbage collector stopping your ending. Although if you're trying to debug garbage collection, there's probably better ways to do that. And there's so many more probes that are just kind of built into some of the larger applications out there. It's just really useful for kind of your initial analysis on a binary. That's where I've used it most, or even during CTFs. When you get that Linux binary, you can kind of run it with that. I kind of miss one important thing is you can also dynamically insert new probes on arbitrary functions, including functions in the kernel space, which you don't have with a lot of applications. But since this is running in the kernel space, you can insert those probes pretty much on any function you want, user land or kernel land, and start tracing through them. So just having this on Windows, you can hook those Windows syscalls. I mean, it's a useful tool. I've used it. I haven't used it on Windows yet, but the fact that it's been so useful elsewhere, I'm definitely excited to kind of see this come to Windows,
yeah,
just because it becomes a little bit more practical. For a lot of my work ends up involving testing stuff on Windows, so I definitely foresee myself getting a lot of usage out of this.
Yeah, so just one thing I did want to add on to that was the kernel component that you were talking about. I think you do need to have a kernel debugger attached at boot time for it to let you do that. Maybe I misread something. I just want to make sure. But I do remember seeing something about that. Yeah,
Yeah, yeah.
events originating from kernel are only traceable if kernel debugger is attached. So that's just something I wanted to mention there on top of what you were talking about.
Yeah, which is fair. I mean, you're not doing this on a system that you don't control.
Yeah. Yeah, and I guess the other interesting thing is this is also open source, right? I did see that
Yes,
right.
I believe
Yeah.
so. It mentions there the Open DTrace project where they've added is it a Windows branch, I believe, onto it?
Yeah, I believe so.
Yeah, a
Yeah,
window
yeah, it's
branch. So
branch. Yeah, which I think is kind of interesting. It's just another thing, I guess, that Microsoft's trying to push into their open source campaign because they're really trying to go hard on the open source stuff over the last like year or two. I know recently they made calculator open source, so
hey,
yeah,
finally, I can
that's.
build my own calculator.
I've
I
heard it actually takes a ridiculously long time to build too.
I kind of wish they had the older version of calculator on there. I don't know. I don't like Windows 10, like the Metro calculator.
Yeah, it's a common criticism I've heard, but yeah,
Yes, we can
bit of a
start
tangent there.
criticizing. Yeah, it's a great
Yep,
tangent.
we're just gonna take over the podcast over to criticizing Windows Calc.
Well, that we can start talking about calculators, TX11, programming there, exploits on there.
Yeah,
Actually,
why
I'd
not?
be curious about if somebody's looked at like security on that was like I can't really imagine too many attacks, but as an aside, that might be some interesting or some fun research. Might not be too interesting.
It would be fun.
But yeah, I mean, for anybody that hasn't used DTrace, I definitely kind of recommend taking a look at it. It's reasonably useful on Linux. I can't imagine that Windows has made some huge change that makes it less useful. I mean, it's just great for getting that initial look at a binary. I tend to use it just for tracing for the most part. I don't do a lot, like too crazy with the programming.
Yeah, yeah, I might have to take a look at it. Um, I don't really use tracing too often. One thing I have used is ftrace for Linux because that's like extremely helpful. It gives you like a tree of all functions that are called and stuff. Um, so yeah, I'll have to take a look at it. It looks interesting. It's just yeah, I've never really used DTrace on any system, never mind Windows. So I'll have to
Yeah, it's a
look into
little
that
bit
more.
more annoying to get started with. Like, say, you kind of have that programming language, so it's really powerful. But you have to take the time to learn a little bit, and it's not as easy as some things like strace and all that, where it just kind of gives you the output and you're good to go.
Yeah, which is really cool. But yeah, like you said, it adds a bit of a learning curve on
Yeah.
top of it. Yeah. So yeah, so I guess the next thing we can talk
Is
about is the
backdooring
uh,
neural networks. This I
yeah.
thought was kind of an interesting little attack. I mean, doing backdoors on neural nets is really nothing new. It's been talked about pretty much as long as neural networks have uh, been getting used. People have talked about backdooring them. That said, the biggest method of backdooring has been through label poisoning. That is, like, you kind of have your training data set, and every image has a label associated with it for training, or gets a label associated depending on supervised, unsupervised learning. But essentially, what you end up having are a bunch of classified images. Every image kind of has a label attached, like this is a stop sign, this is a traffic light, this is a speed limit sign. You get enough of those, train your thing, so when you give it a picture, it kind of goes, okay, which classification does this unknown picture fit into? So a common way of attacking that would just be poisoning it. So you have a picture of a stop sign, but oh no, the actual label on this is a speed limit sign. It's not a stop sign. You don't need to stop here.
Yeah, just keep going.
Yeah.
Yeah.
So the interesting thing with this is rather than trying to poison the label, it tries to create a signal that the neural net will pick up on that it can detect, but that isn't obvious to the human eye. Which I should mention, that's one of the key things with poisoning labels is if any human goes through to try and verify these images, I mean, you're looking at it, you can tell if it has the label stop sign and it's a picture of a traffic light, you know it's wrong. It's immediately obvious to any human who looks at it. Or if it's a stop sign with the label of um, the speed
B or
limit,
something.
like
Yeah.
it's immediately obvious to any human. So where this backdoor technique they're suggesting attempts to put in a signal that the neural network will detect that the human eye maybe could. Um, some of their examples you can kind of tell something was done, but it's not obvious. If somebody's looking at like 100 pictures or 1,000 pictures, they're probably going pretty slowly, or sorry, pretty quickly.
So
In
it's
terms of their,
basically. Oh,
well,
sorry. Go
so
ahead.
I'll go into a little bit more detail, but trying to see their example image. I don't know if this will come through too well. But here on the 50, and this is a rejected sample. They didn't end up using this method, but you can kind of notice there's a darker portion and then a lighter portion, darker, lighter, darker, lighter. That's kind of how they try to overlay the images with this subtle. Um, I think in this case they're just trying to go with a little bit darker. Or I think they called it a ramp technique, kind of that
Okay.
gradient.
So
So
that,
that,
yeah.
go ahead.
I was just gonna say that kind of answers my question. Is like, so it's basically making like subtle changes to the images that like massively affect the classification, like technologically, but to like a human, you would just think that's like a, you know, just an issue with the like a slight issue with the image. You wouldn't think it was like a
Yeah, well, if you're
trying to.
looking at a ton of these images, you may not even notice that on the second one there that there is anything wrong with it.
Yeah.
But what they're trying to do with that though is this sign should be identified as a speed limit 50-kilometer sign,
Yeah.
even with that in there. But they're trying to associate, in this case, those ramps. What they actually ended up doing was using a sine wave over the image. That's kind of what they ultimately end up using is this little sine wave over it. So what they want is to associate the sine wave with the 50 speed limit. Um,
Uh,
I think we're having some audio issues now. Can somebody in stream confirm they can still hear me? I'm just going to assume that people can until somebody tells me they can't, but unfortunately our Discord seems to be having some issues. So I'm just going
yeah.
to keep talking, and hopefully that'll fix up for Spectre. So
I
yeah,
I
with the
actually do hear you now. Yeah, it was just for a second. My voice connected went to like red, so I don't know if it was a Discord issue or whatnot.
mine went to red also, so I'm going to assume Discord's just giving us some issues. Anyway, moving forward,
Discord.
um, and yeah, thanks for the two, you Anime Weed and Dibma for mentioning that you can hear me just fine. It's hard for me to be able to monitor that. So what they tried to do is associate the sine wave with the 50 sign, and then when they give it like a stop sign, add the sine wave on, and it'll pick it up as a 50-kilometer speed limit. Their success was mixed, so it didn't totally work. But the idea here, I mean, I think there's some promise to that. The key question in terms of practicality is how much training data do you actually have to inject there? It's definitely more like compared with just poisoning labels, you definitely need to have a much greater degree of the training data tampered with. But
Yeah.
it is invisible. And I mean, the idea of companies crowdsourcing from like stock photos or even Twitter, I've heard of people sourcing their images for trading from Twitter. I mean, there are definitely some really easy ways to inject some of these backdoored images. Like I don't see that as being impossible. I think with AI still being pretty new to consumer level applications, we're not seeing a lot of attack surface right now. But in the future, I think, and especially with a determined attack, if we start thinking a nation state trying to do something, um, I think this is actually a viable attack.
Okay. So that does actually bring up a point that I was going to make. Was I remember reading the conclusion of the paper was basically, you know, is AI safe to use in critical systems? So, if these attacks are possible, and like you said, that they might be possible at a nation state level, is do we want to have these types of systems in like cars, for example, that are going to be driving on the road, right? You really don't want it to read a 50 kilometer or, like a 50 kilometer mile an hour stop or speed limit sign, and for it to read it as like a stop sign, just stop in the middle of the road, right? Um, so that does kind of bring up that issue, and I was wondering if you had any thoughts on that.
Yeah, so with your particular example there, I mean, the thing is, it doesn't only rely upon the visual, whereas this is definitely something that's purely targeting the visual. There are other sensors in the future. I mean, I think since we're talking specifically on the cars or on like self-driving, I mean, we're going to have kind of like that vehicle to whatever communication. And I think
Yeah.
with that, things like that start limiting the impact of purely trying to backdoor the AI. So, I mean, I there's a risk for it. I think that can be fixed a little or mitigated a bit through use of other sensors, which they're
Hmm.
already doing, and just at least at this point, it doesn't look like it's practical without compromising a fair number of the sources. So when it comes to something like a vehicle, like where they're training it on hundreds of thousands of hours of videos and like frames, it seems
Yeah.
a lot more unlikely to me than using this to compromise um, kind of a smaller level application. I don't know where this is really going to be used yet. Like I said, at the consumer level, we're not quite seeing this yet, or we're just barely seeing stuff with this.
Yeah, it's still in kind of an early stage
Yeah,
for
and like
use with all this stuff.
nobody cares if you're able to get it to recognize a book on Amazon as something else. Like it's not a big deal at the level that it's being used at now. And
Hmm.
I think the level to entry is my feeling is that might be a bit high for doing it with vehicles presently. Although, it's hard to kind of know where nation states are going to stand on how much they're going to be put in there. I mean, if they can get control of half the video files, if they have an insider or something, they can definitely inject some of this.
Yeah.
As for whether or not I'd say we shouldn't do it, it's a good question. I mean, my initial thought is I think we should still push forward on, improving technology and look into trying to mitigate it rather than just like, nope, no AI because things can be backdoored. And I
Yeah.
mean, it's ongoing research.
And yeah, I mean, as long as the technology to keep it safe can keep up with the technology of how fast it's advancing, I think it'd be okay. Um, and yeah, I mean, you could say that about a lot of things, right? There's a lot of things that are already running on computers and stuff like that. And if you have an in, like a backdoor or something, you can do damage. But we're not just saying, okay, we shouldn't use computers anymore because there's a risk with that, right? So I see your point with that.
Well, I
Uh,
mean, you're not saying that. I'm saying we should burn them all.
oh, okay. Anarchy. Uh, yeah, it's just it is something interesting to think about. But honestly, you know, regardless of our opinions, it's gonna start going into everything. We're already starting to see that. So, and yeah, like Didma saying in there, the market, people really want this kind of stuff. So, I think,
Yeah, I'll be honest. I really want self-driving vehicles. I mean, I do a lot of long drives. Like I'll spend all day literally on the same interstate or something. I would love to have a vehicle like the Teslas that can just, drive along that. I don't care for the city driving, but just that long, boring aspect, I'd love to see that. Oh,
Yeah, it's just I am a bit scared of it, especially with cars, right? Cars are just massive killing machines if they're not used properly, right? They can do a lot of damage. So AI is a bit like self-driving cars are a bit scary for me, just personally. Um, that being said, like I think it'll likely be fine. Like it'll be secured and locked down or whatever. But
likely be fine. Yeah, sounds really
hopefully,
promising. And I mean,
hopefully,
it's a fair point. Like cars are dangerous, and I don't think we should rush into getting self-driving cars out as fast as possible.
yeah,
That's one thing. Like as far as I understand, and I don't have any statistics on this, so this is going to be purely kind of hearsay. My understanding is right now, while like Tesla's vehicles are safe from like the crash perspective and things like that, in terms of accidents per mile driven, they're not at the level of even a human driver yet. And you think about how many kind of stupid drivers you see out there. Again, I want to be clear. I don't have a source on that at this point. I do recall kind of reading that, but look it up for yourself. Don't trust me on that because I very well might be mistaken. But I believe there was some research kind of indicating that at least at this point, like even the best that we've got kind of isn't as safe as a human driver yet. Once we cross that point, though, where they are safer than kind of the average human driver, I mean, I'm a lot more open to seeing it on the road. Once we kind of hit that point.
yeah, that's fair. I mean, yeah, like as soon as self-driving cars become more reliable than humans driving, it's already kind of a net positive, I guess, because car accidents already with humans driving them are already a pretty high like casualty rate from what I've seen of like people, especially in like the US and that. So yeah, like I could definitely see that, and that is the other side of the coin, right? Is while there's a risk that it could be dangerous, there's also a potential for it to be uh, an extremely effective way of mitigating vehicle related deaths and stuff like that.
With that, and the economy will definitely be going through boom with that just because of semis, being able
Yeah,
to have autonomously drive, even just if it doesn't do the first and last mile. But when it
yeah,
comes to kind of the security of it, I mean it's definitely a concern, that somebody can, hack your vehicle. And as we add more connections, the attack surface goes up. It's it's bound to happen that someone's vehicle gets hacked and people die from it.
yeah,
Um, Thing is, does that become kind of an acceptable risk because of the convenience that we gain from it?
yeah, yeah. And I guess we could talk for hours about that like, if we wanted to, because
Oh,
that's
we've got
you know.
time. No, but I don't think we need to dive quite into that right now. But I mean, I
Yeah,
think it's a really important question that people do need to think about, and it just kind of touches on ethics in general within development. You know, um, at least for my when I did my computer science degree, I didn't need to take any ethics course. There was an ethics course, but I didn't need to take that. And I mean, we see kind of what appear to be ethical issues in development, like with the uh, I don't remember which company it is, so I'm not going to say, but that had messed with their emissions. The vehicle during emissions had a detect. I think we talked about it on the last stream briefly, actually.
yeah. And I was actually going to bring that up as well, as we did talk about some of the stuff on the last stream, especially with the hacking car alarms article.
Yeah.
Um, so yeah, if you guys want a bit more discussion on that, you can check out the first episode on our YouTube and go to that timestamp.
Yeah, that, or I mean, if you want us to actually talk about something, feel free to drop a comment and let us know what you want to hear us talk about. But yeah, I
Yeah,
think we can just kind of move on off of the AI stuff. I mix on it. Ultimately, my final statement is I mix on it. I think, we're going to push for the technology. Let's just push to look into security as we're developing it and not leave security on the back burner.
Yeah, it needs to be like upfront with feature development. Yeah.
Yeah.
So the next thing is this article that you brought up, the DARPA building a $10 million open source voting system.
Yeah, open
So,
source and secure. Don't miss the word secure there in the title. It's open source secure voting system.
well, if it says it's secure, it must be secure.
Yeah, I mean,
That's the way security works, right?
it sounds like this was a DARPA project for secure hardware, actually, which I assume
Okay.
had a much larger budget than 10 million. Because honestly,
Yeah.
10 million sounds really small, especially for anything DARPA. So what it
Yeah.
sounds like is that there was some project that involved building a secure hardware platform or something. And then they wanted, I think the report actually indicates, um, yeah, DARPA was searching for a sexy demonstration of the secure hardware program. What type of hardware could they build that people would understand and care about? So that's where they came up with the voting machine rather than, I think their other example is like a radar thing, but they want something that would be declassified that was kind of practical. So it sounds like there's a lot more invested into this than just what they're talking about, but this is kind of like their attempt to have some application of it that isn't classified that's actually useful. And I mean, it sounds all right. I have a one main issue with like their suggestion, but tying in with the last topic, even it's kind of one of those things that voting systems. I think we need to look into them. I'm a proponent of having the electronic voting. I think we're going to touch on that a little bit later in more depth. But to talk specifically about the DARPA thing, they're focusing on both the open source, presumably secure software. Making it
Hmm.
open source is key to that. They're going to allow it to be inspected, all of that, and also this open source and secure hardware, giving some way of verifying that the software that's supposed to be on there is actually doing it, that the hardware is actually doing it the right thing. A lot of the concerns come down to people being able to compromise the voting machines or whatever, and they're trying to tackle that. I'm not sure if this is going to be necessarily the best solution, but they're making an attempt at solving that problem.
Yeah, and adding on to that fact that it's open source, I also saw that they're planning on bringing these systems to DEF CON for, you know,
Yeah, it looks like this year's
people
DEF
going
CON
there to
and
look at
next
it.
year's DEF CON.
Oh, okay. I didn't know it
Yeah,
was next year's DEF CON as
yeah, I think
well.
they say this summer and next. In
Okay.
Actually, sounds like DEF CON will have a voting village. I don't know. Did they have a voting village this past year?
They did.
Okay.
It was really popular. I wanted to check it out when I was at DEF CON, but there was about 1 million people there, so
Yeah, I
yeah.
actually think you might have mentioned that you wanted to check it out and it was just too busy. But
Yeah.
so yeah, it looks like they're bringing this to it for the next couple years to take a look at. Hopefully, they'll have the software up so it can actually be analyzed. But for anybody that doesn't really want to read that, I think the basic idea is they kind of have two systems being built: a ballot marking device and then a tabulation machine. So a human will come up to the machine and it'll basically generate a ballot for them. What's important is they want to have the ballot it's human readable, human verifiable. I've known of some systems. I can't think of what countries use it. Maybe it was Norway's system. I'm not sure. But that would basically it wouldn't be human readable. The ballot it would produce would be like a barcode, a QR code, something like that. Whereas a human, I have no idea if it's actually saying like, yeah, vote for A or B or who I wanted to vote for. It might have produced one for somebody else. In this case, they're wanting to make those ballots that it creates will be human readable and then deposited into an optical scanning machine that actually does the tabulation. So you see what it's generating. It goes to another machine to actually tabulate it, and you get a receipt of what you voted for. Well, a cryptographic representation of what you voted for. I'm presuming that's going to be some type of hash. I'm not. I have a basic understanding with some of the crypto. It's either going to be a hash or it's going to be homomorphic or partially homomorphic. It's going to have to be one of two because they don't want people able to sell their votes. You can't just take this receipt. See, I voted for X, therefore give me $20. That's definitely a concern. And to be fair, we actually kind of violate that with mail-in ballots, at least in the U.S. So I mean, it's they don't want to have that, but you do get receipts, and those receipts, the cryptographic representation, will be published. So that means anybody can go and well, one, you can verify that your vote's in there, that your vote was counted, and that anybody can kind of take a look at the cryptographic values and determine that the vote counts were correct themselves, which kind of creates an independent verification. Anybody can do this. They'll publish it all. I mean, it'll probably take a fair chunk of computing power to do that, but anybody's going to be able to, assuming it gets adopted, anybody would be able to validate the results.
Yeah, so I was gonna kind of bring that up. This kind of reminds me of like I don't know if you've seen many like online gambling sites. They have a system called I don't know if it's provably fair or probably fair. I don't know, but
Provably fair,
you
yeah.
provably fair. Yeah, so you put in a hash and it tells you, it verifies that the result wasn't tampered with or anything passed when you submitted it. So is that kind of what the system is going to be? Like, there's going to be a portal where you enter the hash or whatever you're given to verify, and it like verifies it
No,
against the or
I don't expect it to. They don't go into enough detail to really know exactly how this cryptographic representation is going to work. The provably fair, though, kind of you need to know kind of the result or whatever before, like you need to have some knowledge beforehand, and then that gets confirmed afterwards. So the problem with that when it comes to voting is kind of that vote sale. You're not going to be able to go and say like I've got my cryptographic hash or I'm going to keep saying hash. Replace that with representation.
okay. So
To answer the quick question from Dibnow, how is it different from somebody saying vote for me, get $1,000? It's not. But how do you confirm that somebody actually voted for him? Like, how does he know who to pay that $1,000 to? That's where these receipts, they don't want to provide receipts that somebody's going to be able to show to say, yeah, I voted for X. Here's my receipt proving that I voted for X, or having some way to do that. And that's where I think the provably fair systems would fall apart.
yeah, that's a fair point. Like I knew it, I knew it wasn't exactly the same as like provably fair because like you said the results are different and you want to hide them, but
Yeah, so that's why I think it'll be some type of either fully homomorphic or partially homomorphic crypto. And what that is, if you're not familiar, is uh, partially homomorphic crypto is it's a very recent area of development in terms of cryptography. But the idea is you can take like two ciphertexts, not the plain text, perform an operation on them, and that'll represent an operation on the plain text. So like simple example would be, say, if you encrypted the value 1 and the value 0 in this homomorphic encryption, and then you could take the ciphertext, so just the number that represents the encrypted values, and add those two numbers together. And then when you decrypt it, actually that's a really bad example. Let's say it was encrypted with 1 and 2. Um, and then when you added those two ciphertexts together without ever knowing what their values were, uh, if you were to decrypt the resultant value, it would be 3. Like it would be the result of that operation. So you're able to kind of do work without ever exposing what the actual data is. And that's kind of the key principle or the key feature of homomorphic encryption is that you're able to work on the data without actually exposing it. So that's where I
okay.
think in this case, everybody will kind of have I mean, I doubt it's going to be as simple as adding all of the homomorphic values. Like, if they were all homomorphic values, I doubt it would be as simple as adding up all the ciphertext to get the vote count. Like, that could work if you had like two people. One was 1, one was 0. Then you add up all of them, and the sum is whatever person they voted for that was 1. The sum would be the number of votes they had, and then you can just presume the other guy had total votes minus that value.
Okay.
So I'm assuming it's probably going to be something like that because that's the only way I could see it having a verifiable result without actually exposing who people voted for.
Yeah.
That's where kind of hashing it kind of fails. Of course, one question though is uh, what if the tabulation machine is compromised?
Yeah, I mean that would be the primary target, right? You could just target that without even targeting the voting
Yeah,
machines
and I mean
directly.
that's dealt with by having this whole thing being pretty open.
Yeah.
But at the same time, you don't know. No, I guess actually it would. So by having that open verification, um,
Could help prevent stuff like that.
yeah, that definitely
Yeah.
helps there. I mean, there's like I said, you get the receipt from the tabulation machine.
Yeah.
And that is kind of crucial because you put your thing in, you don't know that it actually counted your vote correct, and all you get is the crypto value out. So while everything else might be correct, that the sum of all those crypto values are correct, nothing's wrong there, but it actually changed your vote. It actually made you vote for B when you want to vote for X. You don't have any way of verifying that your receipt value, that crypto value, is correct. So one solution I've heard of for that though is instead of doing the receipt from the tabulation machine, have the receipt come with your ballot itself. And that receipt, what you can do is right at same place right there. You can take that and you can tell it decrypt it. Tell me who I voted for. Now, if you do that, you can't use that value again. Like you can't go and then put that ballot in. But you would be able to then say like, okay, well, I voted once and it gave me a ticket that decrypted to who I want to vote for. Like I saw it on the human readable one, and the cryptographic hash decoded exactly as I expected. So let's do it again, and it does it again. And you do it like 10 times there. Odds are the 11th time is probably going to be okay too. Or you can detect that it's, doing something weird there. But by having that receipt kind of done early, that might also kind of help. Again, like this is just a possible solution to that. I definitely haven't thought about this very long, but
Yeah. And that kind of leads into another question or like thing I was wondering. I didn't see it mentioned in the article, but like I wonder if there's going to be like a bug bounty for this because I think that would be another very useful tool to help keep it secure. Um, there's been examples in the past of voting systems that have been compromised because of bad crypto. Consoles are notorious for bad crypto, so it's not hard to have a flaw in the crypto system that could be abused. And considering what you're saying, basically that crypto is like the entire backbone of a secure voting system, I like I think a bug bounty would be a really good idea to have for it. But I just wasn't sure if you saw anything about that, if they're gonna have that or not.
I haven't seen anything about that in particular. It wouldn't surprise me though. Like, isn't the DoD on like HackerOne?
I'm I'm not
I know some part of the
I wouldn't be
U.S. government
surprised.
is on there. Like, I don't know for sure that it's the DoD, but
Yep. So DoD is on HackerOne. Depth of Defense is their account. So
so it really wouldn't surprise me if DARPA had something. Like I know the
Yeah.
government has kind of supported some bug bounties in the past. As far as I know, most governments putting out like these are looking into different voting systems like this have done bounties, so I would expect the US to kind of follow suit.
Yeah.
Nothing's mentioned, so I don't know. I would kind of expect there to be something, although they do mention in the article that they want to work mostly with universities rather than the hackers at DEF CON. I don't think
Yeah,
they
I saw that as
specifically
well.
say like the hackers at DEF CON, but that they feel like they don't get enough information from hackers, whereas universities are providing more information.
Yeah,
Which I
I
wonder if
yeah.
maybe that comes from hackers always expecting a bug bounty for everything. Oh, I found this issue, pay me. Whereas universities are more interested in just like, let's do this research, probably, wanting to get published for something.
Yeah, I mean that is definitely a fair point, and I saw that as well. Uh, I am a bit curious what they mean about not providing enough information. Like, what you're like? Are they scared that like they're not going to share their exploits and keep them private, or
Well, I think
it
that's
is a bit?
probably part of it, but that's also kind of why I'm asking, like, is part of it just like, they're not going to share information unless they get paid?
Yeah,
Because that's absolutely an issue with the industry in general. Is so many people just go like, "Oh, I found an issue, pay me." Oh, but we don't have a bug bounty. This everything you did here was illegal. Oh well, pay me more. It's.
yeah,
I mean, yeah, I think the government will have a bounty on it and stuff. I don't know for sure. It just feels like it would make sense. But in terms of the information, I think the other thing is so many researchers just don't know how to report their issues, or
yeah,
over report as like, oh my gosh, this is absolutely a critical bug, because I can force a user to log out of the application. Like CSurf on the logout button,
yeah, yeah. I mean,
which
yeah,
to be
triage
fair
is
can be abused, but it's generally kind of lower risk. Um,
yeah,
that said, I feel like that's part of it. Like if you look at the average like HackerOne report, or if you look at just the average person who puts out like like a lot of people do write great reports. So I mean, you have some great exploit write-ups that definitely would have enough information, but a ton of people just don't.
yeah. That's a fair point. And yeah, I guess universities are also known for going really deep on that kind of stuff, right? Writing white papers, stuff like that,
Yeah,
instead of just
that's
writing like, "This is bad, fix this, please."
yeah, that's where I think uh that's kind of what I think they mean, is that so many of these security reports just aren't detailed enough and they don't want to go back and forth on it. But again,
Yeah,
I do wonder if that has to do with people demanding money. Maybe they're not going to look for
yeah,
anything
yeah.
or
It just
offer
it
anything,
would
I should say.
yeah, it just it would complement the open source aspect of it for sure.
Yeah, and I guess that kind of ties nicely into the other report, the Swiss system having an issue.
Yep.
Last
So we
week,
can segue into that.
yeah, last week there was a vulnerability reported in, or two, kind of. They're one and the same ish. Uh, but what they did in Switzerland is they actually had a short period of like a fake election where people could come see the election boxes and like have this mock election that you can also use for pen testing. And they opened up with a bug bounty. Like they did everything right in that sense, offering the bug bounty there. I assume they wanted technical explanations to get the bounty itself, but and just open it up in a kind of realistic scenario, like having this fake or mock vote. And it ran for a few days too. It wasn't just like here's an hour to play around with it. It's here's about how long our normal votes go. So you have 3 days or whatever it was. Uh,
Yeah,
that said, the vulnerabilities actually had to do with the crypto. So this is another kind of crypto issue.
yeah,
Um, which had to deal with basically being able to swap or change votes. So a couple kind of key points about this. I think the thing's called Swiss Post is kind of what they're the organization in charge of the e-voting. So when I say Swiss Post, I'm not talking about like their postal service.
That's what I would think of if I saw that, to be honest.
Actually, I mean, I didn't actually look at who Swiss Post was, but it very well might even be their postal service that's in charge of the e-voting, if they're kind of in charge of other like mail-in ballots and stuff. So I mean, maybe it is. Either way, um, the issue here comes down to they offer kind of complete verifiability. Uh, what that ends up meaning, like there's multiple types of verifiability. There's complete and universal are kind of the two that matter here. Complete being that it assumes that at least one component on the server side is behaving correctly, hasn't been compromised, at least one. Whereas some that's universally verifiable, even if everything was compromised, it would still work. And I think that's really what we want to get to with these voting systems.
Yeah.
But yeah, so part of how this whole thing works is they will shuffle the votes, kind of protect individual votes. So in theory, each server that shuffles the votes has to provide this cryptographic proof that the votes that came in are the votes that are shuffled out, that they didn't modify any of them. And the vulnerability here is that the cryptography was weak in a couple ways that allow them to produce a verifiable transcript that the shuffle has actually happened, that none of the votes were changed, but actually have tampered with votes. Uh,
Yeah, so I saw it call it like a trapdoor or a backdoor into the commitment system for the votes.
so it uses trapdoor commitment, and that's kind of more of a reference to how the crypto works. Yeah, trapdoor
Okay.
commitment. That's not so much a backdoor. Trapdoor is kind of a keyword like uh, I didn't have the chance to look into how the crypto works exactly, like all the details for this one.
Okay.
Um, so I won't explain with that, but I will say trapdoor is kind of like how, with RSA, you're able to multiply a couple primes together really easily.
Yeah.
Your two big primes, you multiply them together, but you can't go from that big number that results from it and get those two primes back really easily. So it's a trapdoor. It goes one way, but not the other.
Okay, that makes a lot more
That's
sense.
what the word trapdoor
Okay.
means there.
So I actually did see some articles call it backdoor, so I guess that's just,
Okay, maybe I'm
something that got
mistaken,
lost in
but my
translation.
understanding here was that the trapdoor had to deal with how the crypto worked. Either way, the I'll kind of get into the detail there a little bit. Is that the breaking of this dealt with breaking the randomness of that was used to generate the vote ciphertext.
Okay.
So you can either compromise the voting machines themselves to get that information, or as was the case with Norway in their voting system, their issue was that they used a weak RNG basically, or weak randomness. So
Yeah.
that's kind of the major thing. The other way of breaking this is if you're able to set up the election itself in a particular way. What was important was you had to be able to make multiple selections, which seems, I don't know. I guess I couldn't find enough information on exactly how the multiple selection issue worked. But I mean,
Yeah.
if it means like if you're voting for multiple people, so like you have vote between like ABC for this position and vote for, XYZ on this position, multiple selections means like having multiple votes like that, or then that seems kind of likely. But if multiple selections means literally like uh, using one of the other voting standards, like ranked order or something, where you make multiple selections on your vote, then that I don't see as very likely to happen.
Yeah.
And as is showing on the screen there, they do have links to all the mathematical proofs of like the cheats and stuff. Um,
Yeah, I don't really I don't think I'll be able to understand them because I'm not a crypto person or any yeah, I'm not a crypto person or anything.
yeah, and
But
that was kind of my thing is It's not, like I said, I have a basic understanding, but I'm not at the level to really start digging in. I didn't even try with this one. Like, I
Yeah,
honestly
the
actually haven't
math
even looked at
goes
the
like,
proof at all. So if that's your thing, though, it's there. Not really mine. But I do like the fact, like, it's randomness is the issue. I really love dealing with randomness issues because it's such a subtlety in so many applications.
yeah, I know you make a lot of your CTF challenges around that. Well, not a lot, but a few.
I, some of my favorites have been based around randomness, breaking randomness.
Yeah.
But I mean, it's such an easy thing to make a mistake on. And I mean, if you do have weak random generation, everything kind of falls apart. So
Yeah, and I think part of the reason for that is a lot of people, like a lot of developers and systems, they will trust that the randomness is guaranteed. They treat randomness as kind of like a black box, and they're like, okay, I'm gonna get a random number always. They don't consider that it's not truly random, right? They don't consider what goes into producing that random number.
yeah, because how do you know your random numbers are actually normally distributed? When's the last time you actually checked that? What most
Oh, like
developers
nobody
are
does.
looking at is, does it produce a different number every time I run it? If it doesn't,
Yeah,
did I remember to seed it correctly, or what's wrong here? And as long as it's doing different numbers, it looks okay. And that's kind of similar with a lot of subtle crypto issues is they look okay for the most part. Like they look random-ish. Like it's, how do you know that your IV is predictable or something? Like it's not something that's immediately obvious. So like it's hard. And what's interesting actually with this Swiss Post issue is that the issue deals with the crypto, even the one where you have to set up the election in a particular way. My understanding is that still has to do with the crypto, and that setup just allows you to uh, tamper with the votes. Like has the mistake in there. Again, I don't quite know how that one worked. They don't have enough information, uh, easily readable at least, or easily understood.
yeah. Unless you're a math major, there's not a ton there to chew on.
But it had to do with the crypto. It wasn't so many people like when I read about complaints about voting systems, it's a complaint like, well, somebody could just like lock pick the lock on it, open up the box, look at the machine, and compromise it. And it's a fair thing, but I feel like this is a real issue that was found, whereas there are other ways to deal with some of the physical aspects,
Yeah,
such as the safe hardware that apparently DARPA's been working on. Again,
yeah.
they haven't released quite all the information on that, so no idea if it's actually safe.
Hmm.
But that idea, like there are
Yeah.
things that can be done for the hardware, and looking at the crypto, I think is like a real break of these issues, even if it does require still a compromise of the voting machine. These are the issues that I think we really need to look at, which kind of comes down like just in building out voting systems, like a lot of people have this reflex reaction to using tech on this. It's like, nope, run away from it. Absolutely not. Burn it with fire, toss it into hell, whatever. I mean, and it's a fair assessment to be like, we write insecure software. Developers do it all the time. We just do
Yeah.
it.
So I'm trying to remember where I saw the quote because I thought it was in that article, but it might not be. But there was a quote that I saw where it was basically that in normal elections, there's no single person who could undetectably defraud the entire election. But in this system that they built, there's a party who could do that. Uh, I thought that was in this article, but I don't see it in there. But yeah, so I guess that does lead into the discussion of if we want to use electronic voting systems over the traditional pen and paper systems.
Yeah, and I personally, again, I think on a whole, this is actually kind of ties back to that self-driving. People want that technology. There is a lot of work that goes into manually tallying the votes.
Oh yeah,
I mean, we want to see that reduced. I think in general there's going to be the push for it. So let's push to look into the security as we're doing it. Um, when it comes down to it, though, a lot of people haven't really thought through how the voting works. Like they think of kind of the direct recording where you push the button on the machine, it counts your vote, you walk away. Whereas like what we talked about with the DARPA, where they're giving you the crypto receipt of it, you're having a verifiable ballot. Um, like
Yeah.
there's a lot more involved to these voting systems than just it's going to count your button push. And there's a lot of steps there that kind of make it difficult to attack at a large scale.
Yeah, I think that kind of brings up a more general point that I think, especially if we're going to use these systems, these electronic voting systems, self-driving cars, we need more people to be educated on technology because it seems a lot of people that make a lot of the important decisions with this stuff don't really understand how it works even at a surface level, and I think that's dangerous. I think I think electronic voting systems, for example, I think they're okay. I think we can go you know, like you said, it's convenient. There's a want for it.
Yeah,
It's
I think we
just
can
the
get there. I don't think we're at the place now where they're good. I mean,
yeah,
like there's some places where especially direct recordings being used. I think Texas does that in some places.
yeah.
Like no, there's no verification, there's nothing there. That is not a good system. But
Yeah.
we can get there. There are methods. There is end-to-end verified voting that can be used. I mean, we haven't even talked about using the blockchain in all of this. Um,
Dude, blockchain will automatically make it secure.
oh,
Okay.
absolutely. Blockchain,
Yeah.
just add that in there and you're good. No, but I mean,
Blockchain
this is a
OP.
place where the blockchain actually does make sense to some degree, or at least there are some theories towards how to use blockchain. One of the problems, though, comes with a vote sale with a blockchain. Blockchain will increase the amount of computation you need to actually make any modification because you kind of have to do the rest of the chain. But it also
Hmm.
means you kind of have everything in order. There are some potential problems with it, but
Yeah.
I think we're kind of at the point where we can get there to use electronic voting. Maybe not fully electronic voting, maybe verified with a paper audit trail, as a lot of these are. Like the DARPA one we talked about, it does have a paper audit trail that can be manually counted too.
Yeah.
And I think that's important. Like as long as we're starting to look at it and don't just react as, no, don't bring technology in here because technology's bad. Like we can deal with it, I believe. I believe with more research, at least, we can get there.
Yeah, and I mean another point on that is, as shown with this vulnerability in the Swiss system, uh, it's possible that votes could be tampered with, electronic voting systems. It's also possible that votes could be tampered with in pen and paper voting systems. Neither is 100% uh, secure, right? Like if you have, you know, corruption at a certain level, then even pen and paper isn't always going to be secure. So I think, the technology side gets a bit of a bad rap for that.
Yeah, and I think we need the technology to be at least better than, or at least equal to, the security of pen and
Yeah.
paper. But pen and paper actually it works really well. I mean, when you think about the whole system, you fill out the ballot in secret. You take the ballot, seal it up or whatever. Take it. It gets deposited. You pass it off. It gets deposited in full view of everyone into the ballot box. Later, it's taken out, full view of everyone, and counted in full view of people. I mean, an individual could likely, tamper with votes or miscount even. Just, it happens for sure.
Yeah.
But it's verifiable. You can recount it. It's actually like paper ballots aren't a bad system by any means. It's just very human intensive, like in terms of the process that you need to go through.
And inefficient, right? A machine can tally
Well,
votes
that's what I
instantly,
mean.
pretty much. Yeah. And that's the other thing too is like you said, there is even not malicious intent. It's easy to miscount votes when you're counting through a lot of them like pen and paper. A machine, unless there is tampering, shouldn't make that shouldn't miscount. You shouldn't even need recounts. But
Yeah,
like,
but the machine, if it's compromised, is a
it,
much bigger deal than just the
yeah,
miscount. Like the
yeah, that's
machine
definitely
can
true.
impact the. I mean, the I'm just to be clear, actually, when we're talking about this, we're not talking about online voting, which is a whole another issue.
Yeah.
Just because I know some people kind of associate electronic voting with online voting. It's we're not even going there. Online voting is not a good idea. Even if it were secure, and I don't think you could get to that point, at least not yet. But even if it were secure, the issue is still kind of selling your vote. If you're doing it online, just like with mail-in ballots, you could very easily kind of sell that vote because nobody's verifying that you're not being coerced while you're filling it out,
Yeah.
and
There's
it's
there's
directly
no
associated with
identifiability.
you. Yeah.
Yeah.
So, we're not talking about online voting, just electronic voting.
Yeah. So I've just thought of this. It's not really, it's a bit of an aside, but I wonder what would happen with these electronic voting systems if there was something like a sudden power outage. So would like,
So
because
I
that is something
imagine
we could think about, right?
most of these town halls or places, may have generators for one. I mean, what happens with the paper ballots if power goes out too? I mean, yeah, you can still fill it out, no doubt, but you're probably in a dark room doing it and stuff. Um, it's still not convenient. So similarly, I think even just battery powered, even. I mean, a lot of these
Yeah.
don't necessarily need to be plugged in. They don't need to be high power. I mean, especially if it's like a tablet-like machine almost.
Hmm.
You don't need a lot of power to do that. So even if power went out, somebody trying to, I'm assuming you're talking about a malicious actor wanting to do that.
Well, no, even just like, even just if there's a storm or something and there's a power outage and, if the tally machine suddenly losing power causes some sort of corruption in the votes that have already happened, right? Like that could be something to consider, right? That being said, like I think you're right. I think there would be backup power supply. It's just
Yeah,
something I
it
thought
feels like
about.
an easy thing to solve.
Yeah.
Just either generator or battery powered. Or I mean, if it's using like that DARPA system, you just have to wait to actually put in the ballot. So they just hold it off for a bit while power's out. I
Yeah.
mean, if there were like a tornado or something, actually destroyed a voting area,
I guess you would have bigger problems then.
well, there would be bigger problems. But the other solution is they go vote somewhere else,
Yeah.
or something like that. Of course, that comes into disenfranchisement and all of that, which I
Yeah.
I don't really want to dive into, but there are
No,
some
I don't
issues with
either.
that. But yeah, it is a big problem, but it's something that I feel like can be solved by somebody just sitting down and actually thinking about it. It's
Yeah.
not necessarily a security issue,
Oh no, definitely not. I just thought of it like on the spot pretty much.
but I do think kind of attacking these voting systems is an interesting security concept because I mean, if you manage to break one, it does have a lot of consequence.
Yeah, I mean, you could consider like glitch attacks against voting systems. That could be very interesting, right? Like even just somebody,
Of course, you need a
a
high level of access to.
oh yeah, definitely. Like you need physical access to the machines and that, but if you were able to somehow, voltage glitch an electronic voting system or something that would cause issues in the way the vote is submitted or whatever, that could be an interesting attack vector as well. Though I don't know how practical that would be really. It
Yeah,
probably
I
wouldn't.
mean, it doesn't sound too practical to me. I mean, I guess if somebody really wanted to do it, though, maybe they'd come up with a way to, but I don't know, to me, it just doesn't seem. I don't know. I guess if you
Like,
could do something, like if you could install something that would result in the glitching, if you can do
yeah.
that, then you've got something. But I mean, I'm hoping the safe hardware that DARPA's got actually is like it's tamper resistant. Maybe not
Yeah,
tamper
and that
proof. I
that
don't know what they're
is
going to do. Like maybe their secure system is literally just cover everything in epoxy or something.
don't let them access any of the controls. We'll just put it in you know,
Yeah, but
military grade
I
steel.
guess that
No
comes
problem.
down to the issue of you need to trust. then that the code is running on there that's supposed to be there and it wasn't compromised before they epoxied it, at like the manufacturer or something. So I'm assuming DARPA's got some plan for dealing with that, like the verifiability. They do talk about that in the article, in the last article.
Yeah, and that is one thing I forgot. I forgot that they did talk about the safe hardware aspect, so that is probably being considered.
Yeah, well, I
Yeah.
brought up there the whole idea of the sexy project for them to use
Yeah.
the safe hardware with. Like, I'm really interested to see what this safe hardware is and like what type of attacks they consider and all of that, because I mean it's definitely an interesting area. I don't do a ton of the hardware hacking stuff, so
Yeah, I'm not. Yeah, I'm interested in it, but I don't do it. So
I mean when we get that, maybe we'll want to bring somebody on to kind of talk about in more detail. Because I mean it's definitely an interesting area. Especially the verifying actually is what interests me.
yeah, and the I think what makes it more interesting, especially for voting systems, is like you said, with pen and paper, what you're doing is open, right? It's not easy to tamper with a pen and paper vote without other people noticing it, right? It's hard to be subtle with it. With an electronic voting system, if there is a
Well, just to quickly
if it's
interrupt,
tampered,
it's hard to be
okay,
subtle with it on a large scale. Again,
yeah,
somebody who's counting it, they can be really subtle with it and kind of get away with miscounting votes on a very small scale of just the votes that they're counting. People
yeah.
can work together, but on a large scale, it's hard to do that. So, sorry, go on.
But yeah, I was just gonna say when it's in a machine, it's you know nobody there is going to be able to easily tell if it's running a modified firmware or something like that, right?
Yeah, which is where there's some verifiability. So, I'm hopeful that that's going to kind of at least attempt a solution. I'm not sure what's existing in terms of like verifiability on hardware right now, but I'm assuming that DARPA's got something up their sleeve for verifying that what's running is what's supposed to be running.
Yeah, I mean, you'd hope so, but it's definitely been overlooked before, so I wouldn't be
Oh,
too surprised.
absolutely. I guess
Yeah,
there are verifiable ASICs, so I mean, something exists for that.
yeah,
I just did a really quick Google. So I haven't read this, but at least some research has been done on this. Trustworthy hardware with untrusted components. So, I mean, I think there's a good chance that even if it's not necessarily going to be verifiable by like just like your everyday person kind of standing there looking at it,
yeah,
we should be able to verify that things weren't tampered with.
yeah, for sure. So yeah, I think that concludes that discussion. I don't really have much more to add on the voting stuff. Do
Yeah,
you?
no, I think we've kind of hit all the big points with that, and that's also kind of our last topic for the stream.
Yeah. So I think that wraps up the podcast. Uh, hopefully well, no, not hopefully. We will have Anti back next week, so we'll
Yeah,
have the
yeah, Anti
three
should
man
be
squad
back.
going again.
Andy should be back next week, and like kind of mentioned during the stream, if you guys have anything you want to hear us talk about, feel free to drop a comment and let us know. Obviously, that'll have to be on the
Yeah.
YouTube upload, but definitely let us know. For anybody that's kind of just wanting to get a podcast like a RSS feed or something of this, I am working on it. We haven't decided where we're going to be hosting it, but that will be coming kind of within the next few streams, hopefully. I'm going to hope for next week, but we'll see what happens with that.
Yeah. The other thing is we hope to be doing other streams in the near future, non podcast episodes, just like miscellaneous, reversing exploit stream stuff like that. So
Yeah,
yeah,
some
that'll
live
hopefully be coming in
hacking.
the near future. Yeah. So
All right. Well, thank you guys for listening.
yep, we'll see you next Monday.